on justifying algebraic properties. In order to justify our properties, the first thing we need to do is have some vocabulary to help us with our process. So our first property that we want to look at is the addition property of equality. What the addition property of equality says, if you add the same number to both sides of an equation, the sides remain equal. So we have a math way of writing this. We have if A equals B. So we're saying if this side, the left side equals the right side, then if I add something to the left, so if I add C to A and I also add it to B, they will remain equal with each other. Okay? So if you add the same thing to both sides, so I added C to both sides, they remain equal. That's your addition property of equality. Now for our subtraction property. So our subtraction property says if you subtract the same number from both sides of an equation, then the sides remain equal. So it's very similar to the addition, it's just a subtraction instead. So we have if A equals B, then if I subtract the same number from A and B, they will remain equal with each other. I bet you can make a prediction about the multiplication property. Let's see. So, if you multiply both sides of an equation by the same number, the sides remain equal. So if we start off with A equaling B, if I multiply A times C and I multiply B times C, they will remain equal to each other. Alright, our division property of equality. Alright, so if you divide both sides of an equation by the same number, the sides remain equal. So if we start off with our original equation, if A equals B, if I divide A by C and also divide B by C, because they're equal to begin with, if I divide by the same number, they will remain equal. Alright, and then our next property is the symmetry property of equality. So the symmetry property states that we can interchange or change places, is what that means, the sides of an equation, and the equation will remain true. So if we have, if A equals B, then B equals A. Where you're most likely to see this is sometimes when you solve an equation, you end up writing your answer like this because of where the variable was. The proper way to write it is the other way around, x equals 3. And so that would be your symmetry property to make it look like that, to take it from here to there. Okay? Now, your distributive property of equality. If you are multiplying a sum or a difference by a number, you may distribute that number, then add or subtract for the same result. Okay, so what that's saying is if you have A times B plus X, so this would be multiplying a number times a sum, you can distribute that and have it equal the same thing. So these are still equal to each other. Okay? And our last property that we want to look at is our substitution or combining. So our substitution property says you're going to add or subtract multiple terms together if they have the exact same variable to rewrite them as a single term. So say we had 2x plus 3x minus 8x. So here we have three terms. They have the exact same variable with the same exponent on them, so they are like terms. We can combine them together. So 2x plus 3x is 5x, 5x minus 8x is negative. So instead of using three terms, I'm now writing it, I'm substituting in negative 3x or combining my like terms. Alright, let's go to some examples. So the purpose of this is you are going to use these properties to justify why you're allowed to make your solving steps as you solve equations. So I gave you your properties. I just want to remind you, don't forget about the substitution. Combine like terms. You can use either word. and your symmetry property. Okay. So keep these in mind that we just talked about. So first thing, the first line is always given. This is the problem we're trying to solve. So it's given to us because otherwise you couldn't solve it. Then what we're going to do is we're going to compare line 1 and line 2 and see what changed between the lines to determine which of these properties allows us to do that. So it looks like they distributed the 2 through because that was 2 times the difference of, and now it's 2x minus 18. And what allows us to do this is our division property of equality. So this is my reason for being allowed to do this. Now we're on step 2, we're going to go to step 3. So we want to look at step 2 and step 3 and see what happens. So we still have the 2x. Then there's a minus 18 here, but it's missing in this one. And there's a negative 10, but it's a changed number here. So it looks like they added 18 to both sides. What allows us to do that is our addition property of equality. So you're just telling me what math you're doing from 2 to 3. Now let's look from 3 to 4. What's changed between 3 and 4? In 3 we have 2x equals 8, and in 4 we only have x equals 4. So how did they get rid of that 2? Well, this is 2 times x, and to undo multiplication you have to divide. So I'd have to divide by 2, and remember you have to do it on both sides. So which property says we're allowed to do that is our division property of equality. Alright, so up here I said division. Well, I said distribution, but I wrote division. So we're going to make sure this says distribution up here, not division. That was just, I miswrote. Okay, let's look at problem number 2. So we have a fraction. I know we don't like fractions, but we're going to justify our steps and solve this. So the first line is always your given because that's the problem you're being given to solve. Then you compare line 1 and line 2. How are they different? Well, this one has the fraction plus 10, and then line 2 only has the fraction. And the negative 1 is now negative 11. It looks like they subtracted 10 from both sides. And what it allows us to do that is our subtraction property of equality. Now, let's compare line 2 to line 3. How are they different? Line 2, we're dividing by negative 3. Line 3, we're not. Line 2, we have negative 11. Line 3, we have positive 33. What did they do to make that happen? So it looks like they multiplied both sides by negative 3, because that makes this one cancel with that one down there, leaving just the m and the negative 11 times negative 3. And this positive 33. And so that is our multiplication property of equality. So overall, these are not terrible. You just have to know what the properties are to understand the solving process. Okay. So what I want you to do is pause the video and try number 3 all on your own. All right, well, let's take a look. So we have a fraction here with a 2 on the bottom. We want to get rid of the 2. So we multiply both sides by 2 to cancel it out. And we're allowed to do that because of the multiplication property. Then to go from line 2 to line 3, the difference was there's no minus 1 there, and the 14 became 15 because they added 1 to both sides to cancel the 1 on that side. We're allowed to do that for our addition property. And to get 5y equals 15 into y equals 3, we divided both sides by 5, and we're allowed to do that by our division property. All right, let's take a look at the back. All right, we're going to skip number 4 and go straight to number 5. So our first line is our problem that's given to us. We have given. Now, how did we get from line 1 to line 2? So the 5n is missing. So what does that mean? It means they had to subtract it from both sides. So we're allowed to do that because of our subtraction property of equality. Okay. Now we're going to go from line 2 to line 3. It looks like the negative 42 became negative 6. The 7n became just 7, so they got rid of the 7. They divided both sides by 7, and we're allowed to do this because of the division property of equality. Okay, now we have negative 6 equals n, and then the line 4 is n equals negative 6. So all they did was interchange them, turn them around, and remember, that's what we call the symmetric property. Okay. So we can skip number 6 because it's pretty much the same as another one we did. And what I'd like you to do is pause the video and try number 7 all on your own. Alright, let's see how you did. So we had our given, and the first line, they distributed the 2 and this negative 1 over here. That's a negative 1. So that changed the signs of what was inside. And we're allowed to do that from our distributive property. And then to get from line 2 to line 3, this was a tricky one. See, we still have this negative 2x, but the 14 and 16 are gone, and I just have a negative 2. That's because on the side, 14 and negative 16 are like terms. So they combine down to the negative 2. When I look at the other side, I have 5x minus 3x that are like terms together on this side, and 5x minus 3x is 2x. That's where that came from, plus the 34. So that's a combined like terms, or you could have written substitution. Okay. Now, how do we get from line 3 to line 4? We still have the negative 2, but negative 2x became negative 4x. Okay, so how would that happen? When I look on the other side, the 2x here is missing. So what it looks like is they subtracted 2x from both sides. So see how I get negative 4x there, and here they cancel. So that's our subtraction property of equality. Now how did we get from line 4 to line 5? We have negative 4x minus 2, and here's just negative 4x. The minus 2 is gone, so they would have added 2 to both sides. That's your addition property. And how do you get from negative 4x equals 36 to x equals negative 9? Well, to get the x alone, you'd have to divide by negative 4. And we're allowed to do that for our division property. All right, we'll try this in class. See you soon.